What's up, everybody, and welcome to a quick little lecture video on just like an intro to the periodic table and organizing the elements. If you were lucky enough to experience my failed Zoom meeting, good for you. I know I'm going to repeat myself, and you may have heard this before, but why not? It's a periodic table. It's the best thing in the world. Well, maybe not the best thing, but one of the best things in the world. And here we go. So it was all developed by a Russian chemist by the name of Dmitry Mendeleev. And Dmitry Mendeleev had a very interesting life. There's a great Crash Course Chemistry video on it to watch if you have not seen it. Just to kind of find out a little bit of his life. And his main goal was to find a way to organize the 60 or so known elements of the time. And the time I'm talking about is the 1860s and 70s. And so he searched for a way to organize these elements because really there weren't a whole lot of organizational systems that a lot of scientists would agree upon at this point. So what he did is he put the names of all the known elements and their properties and their atomic weights on a card, kind of like an index card, and he played what he called chemical solitaire, or something very similar to that name, and he would place all these different cards down and try different arrangements until he had a pattern that he liked. And it took him years, and what he ended up finding is that the pattern he landed on, or the arrangement he landed on, was mostly based on increasing atomic masses. And he discovered a repeatable pattern that occurred when he arranged the elements this way. All right, we call this arrangement the periodic table because the pattern was repeatable, and something being repeated is called periodic. So, in the periodic table, nowadays we have atoms arranged by atomic number, and we'll get to why we changed from weight or atomic mass to atomic number a little bit later. But we can see them arranged by atomic number, and the periodicity that we see, these periodic patterns we see repeated, are the physical and chemical properties of the elements. Now, Mendeleev's true genius was to leave blank spaces in his table. And this was to keep the elements properly lined up according to their chemical properties. And he made a couple changes on his periodic table as time went on. And I'll talk about a few of those as I keep going on. The other thing he was able to do from leaving these spaces is he started to predict the properties and masses of elements that had not yet been discovered. And so as he found these, as these were discovered, people looked at his predictions, and some of his predictions were really close. All right, he had an element called exosilicon because it was going to be right below silicon on his periodic table. It actually got the name of germanium. Germanium was discovered in 1886, about 15 years after he predicted what exosilicon would be like. He was pretty close on the mass and the density, and even the density of the oxide of germanium or exosilicon. All right, he got the color pretty close, and he did have the melting point pretty close too. And he predicted other elements. His predictions were similarly accurate, although I believe exosilicon and germanium was the closest he ever got. But he also predicted element number 31, gallium, which is right before germanium. And right below aluminum on the periodic table. He predicted a lot of those too. And he would argue against people who said they found these elements and didn't have data that matched with his. And it's quite a fun and little interesting story. And his table, originally, he had the atomic masses generally increasing, gradually increasing from left to right. And if we look at the modern periodic table, this is pretty true, although you will see some examples like cobalt and nickel, where the atomic mass actually goes down. Cobalt is number 27, has a mass of 58.933. And nickel is number 28 and has an atomic mass 58.693. So the atomic mass goes down a little bit. And then maybe the most famous example are elements 52 and 53. These are in groups 16 and 17 in period number 5 on the periodic table. Tellurium and iodine, where tellurium has a mass that's almost a full atomic mass unit greater than iodine. And what Mendeleev did here is originally he had iodine before tellurium, but then on one of his revisions in the early 1870s, he actually flipped them and kind of made the decision that properties of the groups that go the vertical columns were more important than keeping the trend of masses going. In 1913, Henry Moseley, the other big periodic table scientist guy you guys need to know, kind of cleared this up a little bit. The nucleus had been discovered within the 5 years before Moseley worked, and what Moseley ended up doing through some X-ray experiments, he was able to determine the charges of the different nuclei, and he set hydrogen's charge equal to 1, helium to 2, and he noticed every single element they knew of had a unique charge, and he numbered them from lowest to greatest by whole numbers, 1, 2, 3, 4, and so on. And he called this the atomic number. And if you arranged the elements by atomic number, you got almost the exact same table as Mendeleev's, which was discovered 40 or so years earlier. But it kind of solved out these different mass issues. And so cobalt and nickel switched. It confirmed Mendeleev's switching of tellurium and iodine to what it has become today. All right, currently, we use Moseley's arrangement of the elements. We do it by atomic numbers. And if you want to take a look at the periodic table, it's on pages 500 and 501 of your digital textbook. Finally, I just wanted to show you guys a little picture of the periodic table. This one is as similar as one that I could find to your textbook one online. All right, I know it's kind of shrunk down there in the corner, but go to pages 500 and 501 and you'll be able to see yours. Big things you need to know just about the layout of the table. The vertical columns are called groups, also known as families. All right, they have similar properties to each other. All right, they have the same outer electron configuration, so chemically speaking, they are all very similar to each other. They form the same types of ions in ionic bonds. They form the same number of covalent bonds. And we won't get too much into those bond types right now. I don't even know if we will in this course. But, when you take chemistry in a couple of years, you definitely will get into those bond types. The horizontal rows on the periodic table, the horizontal rows are called periods. All right, the properties repeat in every period, all right, to kind of form those groups. These are the periods right here. There's 7 of them, whereas the groups are numbered along the top. Now, it does look like the periodic table is can be broken into 4 parts, and there's a very good reason for that. But again, that is beyond the scope of what we're talking about right now, so I'm not going to talk too much about it. The only other thing I really want to point out on the table, and it's kind of all here for you already, is if you look, all these blue boxes here, these are all metals. If you look, the majority of elements on the periodic table are metals. The yellow boxes are your non-metals, and the green boxes are your metalloids, which are sometimes called semi-metals. These two right here, polonium and astatine, they are listed differently in your textbook than they are listed here. And there's a lot of debate on whether those are more metalloid or metal and non-metal, as your textbook says. And then these ones down at the bottom, your book has kind of classified them as metal or non-metal, but many of their properties are just predicted because they've only been around for a couple of seconds. A lot of these newer, very bottom row elements down here have been discovered in the lab by smacking other particles together at really high, almost the speed of light speeds in Large Hadron Colliders, like the one in Bern, Switzerland, that we know of. All right, and that is all I have for you on the periodic table, and a quick little thing. You'll get more out of the textbook pages, which for you guys is chapter 16, section 3. It's around page 500, and that is it. So take it easy, guys. Bye.